Banking fees have received much attention during the recent economic recession as banks look for ways to recover from the crisis. A sample of 37 customers paid an average fee of $11.95 per month on their interest-bearing checking accounts. Assume the population standard deviation is 153. Complete parts A and B below. In this homework problem, we're going to use Excel to calculate the margin of error. Remember, the margin of error is what you add and subtract from your mean, your sample mean. So when Excel calculates the margin of error, you don't have to find the z-score and the standard error of the mean. It's already going to be multiplied together for you. So once you do get that from Excel, all you have to do is add and subtract. So let's look at how that will look in Excel. So you're going to do confidence, believe it's this one, .norm. All right, alpha here, it says that 99%, so alpha would be 1 minus 0.99. Remember when we were going over this, let me see if I have it. I don't think I have it on that. Let me go to the slide just to review, because you have to keep all of this straight. And these PowerPoint are really good to help you keep that straight. Let's see if I can find it. Okay, so alpha is the significance level. It's the probability that it will not contain the true mean. So in our problem, 0.99 is the confidence level, so 1 minus 0.99 would be alpha. So 0.01, and then we want the standard deviation. And the standard deviation for the population is 153. And then we want the sample size, which is 37. So our margin of error here is 0.65. Okay. And so I believe we're going to, let's just see. All right, so what is the margin of error? We got 0.65, which is correct. So now all we have to do is take the $11.95 mean. We're at this step right here. This is what we're going to use. We can skip the z and all of that because we're going straight to adding and subtracting the margin of error, which was 0.65. So if you do 11.95 plus 0.65, you're going to get 12.60. And you can double check that. And then you do 11.95 minus 0.65 and you're going to get 11.30. So that's how you calculate the standard error in Excel. Alright, so here it's the same thing except they give you the alpha. So for the first one, alpha is 1%. And N is a random sample of 31 taxpayers. So that is going to be N. Your average mean, this is what you're going to add and subtract your margin of error from. And then the population standard deviation, you will need that for Excel. So let's go ahead and calculate our margin of error. I think alpha is still 1% here. Okay, for the first one. But we need 31 for N and 2410 for standard deviation. So the standard deviation is 24.10. And the sample is going to be 31. So here is our margin of error. So we're going to add 1115 to, let me check that real quick. I had to go back and fix that because I put 24.10 instead of 2,410. So here is our margin of error, okay? And it says to round to the nearest dollar, so that is going to round to 1115. So we're going to do 1115 added and subtracted to 95.98. So 95.98 plus or minus 1115. So if you do 95.98 plus 1115, you're going to get 10,713, okay, which is what we get here. And then if you do 95.98 minus 1115, you're going to get 84.83. Now notice in these problems, you are skipping, you're saving a lot of work because you're not having to figure out the probability to look up the z-value, and you're not having to calculate the standard error of the mean. Those have been multiplied together, and you get the margin of error from Excel. So all you're really having to calculate is adding it and subtracting it from the sample mean. You're going to do part B and part C the same way, except alpha. All you're going to do is change alpha to 0.02 and 0.1 in Excel. I'll just show you. Only thing you would change would be 0.02 to do the 2%. And then add and subtract that from your 95.98. Question 7 is the same way, except they're giving you your confidence interval, and you have to do 1 minus your 93%. They're giving you your confidence level. Remember, your confidence level is 93%, okay? To get alpha, this is the percentage, well, the probability that the confidence interval will contain the true mean. Alpha is the probability that any given confidence interval will not contain the true mean. So these together should add up to 100%. So you're going to have to calculate that. Just do 100 minus 93, so that'd be 7%. So alpha is going to be 0.07 for the first one. I'm just looking at the first one. And then your N is going to be 36 adults. So you would change 31 to 36 for your sample. Let's see what our standard deviation is. 253. So you're going to change that to 253. So here is our margin of error, 76.4. And we're rounding to 1 decimal place. So our average is 2135. So we're going to do 2135 plus this, and we're going to do 2135 minus this. So we get 211.40. 2211.40. Did I say that? Yeah. And then 2058.60. Okay? So question 6, they gave you alpha. Question 7, you're having to calculate the significance level. They're giving you the confidence level instead of the significance level. And question 10 works the same way, except we have 98% confidence. So or alpha would be 0.02. So you're going to plug in your information. You're going to do 0.02. Your standard deviation was 914 and M was 18. So you get 5.01. So when I add 501 to my 36.61 up here, my average, when I add and subtract 501 from it, I will get these two numbers. And since the sample is less than 30, I'm going to have to assume the population is normally distributed. Let me know if you have any questions.